Hi, welcome. It's September 2021, 6 p.m. here in the UK, and welcome to IoT North. We've got a great show with Olivier again and my good friend John Stavely. Hey, thanks very much for joining us. It's a great day and very sunny out here in the UK. So if you are watching this live, I really hope that you're enjoying this in the sun. We had a competition to win some gold tickets to the IoT Expo event, and I'm pleased to announce that Vision Intelligence won that. All they had to do was submit one of the use cases to our marketplace. We will hopefully have more competitions coming along. If you'd like to promote your IoT solutions and use cases, please do go to iotnorth.uk/marketplace and register them there, and we'll add them onto our social profiles and promote them and find customers for you and connect you with them. We also have the forum, which is now sponsored by DigiKey for the next couple of months. They're promoting their Future Factory. If you'd like to take a look at that, please, we've made this space for you. Please do join it. Have a look at the information that's on there. If you have any requests about shows, if you'd like to speak, if you'd like to hear about something, that's the place to put it. If you have any information about what you're doing, please do add it there, share it with the community, and let's have a chat about it. Today, say hello. If you've got any questions with the show, please do ask them. We'll share them on the screen and we'll answer live with you. And today we are going to be talking about Microsoft Azure with Olivier. So let me bring the guys in. Hi, guys. How are you doing?
Hey, how are you?
Yeah, good. Leeds has hit 28 degrees, so I'm melting at the moment. You might hear my fan, a jet engine going on in the background. That's trying to keep me cool and not succeeding.
It's the only reason why I didn't point that out today is like I usually do, is because I can understand how hot it is. However, it's only 23 degrees here.
Further north, see.
But, It is up the north, near snow. Not really. We don't get quite as hot as Leeds, do we? Hey, Olivier, how are you doing?
I'm great. Here, over here in the Seattle area, we're getting the climate that Californians used to get 5 years ago. So it's pretty neat. Not too hot, and it's not raining at all. Pretty nice, shiny sun, and we had a good summer. So we're not hot and we're not cold, so that's perfect.
Yeah, absolutely brilliant. I wish we'd had that. We haven't had the best of summers this year. I think it's been grey more than anything over here in the UK. But hey, so what's the cool new tech that you've been coming across recently, Olivier?
Oh, there's a lot. Here we are actually continuing. Last time I came to chat with you guys, I didn't have time to go through some of the demos I had, too many of them, and we're talking about simplifying IoT. And in terms of simplifying, we discussed what's going on the devices themselves, how it's important to simplify how people are developing for devices, and how they're developing their cloud applications as well. The one thing as well that I wanted to bring up was how we are simplifying, or how it's important to simplify the intelligent edge story. And for that, I brought some slides and so on, but I really want that to be a conversation. So both of you guys, feel free to just chime in and ask your questions. I will go through, as I was saying, a few slides and then some demos. The objective here is to spark the conversation and bring up questions and so on. I'm using Microsoft technologies. I work for Microsoft. I'm part of the Azure IoT group, and I'm looking after our community engagements. So my role over here is to, share about the goodness of the things that our teams are working on. I'm embedded into the product team, which means that I'm not in a marketing org or just in an advocacy role. I'm here to help our engineers talk to you guys, talk to the community of developers, understand better what the developers' needs are, to bring that back up to the products, tools they're developing. So that's really the core of it. So let me jump into the topic. And hi to people who are joined, and hopefully you're gonna appreciate the demos and the speech today. So let me switch to that view here, where you have a little bit of slides. And what I want to first start with is discussing a little bit with what is the edge. We're talking about simplifying the intelligence at the edge. And first, let's agree on what the edge is, because the definition of that word has been like IoT a few years ago, has been different for different people. So if I look at this diagram here, this is what IoT is about. You have the cloud, you have devices are connected, they're starting sharing their information, they're coming from their sensors, and they are sharing that between each other or through a gateway to the cloud. And eventually you can have business application making the most out of that insights that it extracted from this data. And your applications are evolving, your businesses and business models are evolving, and so on. So that's the gist of IoT. So in that's what the edge is. Everything that is not cloud, everything that is not the business application. So the connectivity, the security, the telemetry, the analytics as well at the edge is what we'll talk about today. This is what the edge is about. So when we talk about the edge, it's a lot of different things. If you talk about the edge to someone in telecoms, they will tell you that the edge is a server next to that antenna for LTE that offers some intelligence. Someone else will say the edge could be my factory. Someone else will say the edge is the little sensor in my aquarium to monitor the temperature of that aquarium's water. So that's really what these things are about. And you would wonder, why would you want to make the edge intelligent? We've been in that pendulum, that's the way I'm describing it, in the last 20 years about embedded and IoT technologies. Embedded was about making intelligence smart, bringing software down there, and being able to have some reactivity from the devices themselves. So today, for example, in cars, in the car you're driving, you have like 15, 20 years old technology that brings a level of intelligence with microcontrollers that allows autonomy of certain reactions and behaviors of the car. That's just an example. But we were at that point where we wanted to have these devices being intelligent. And we're talking about smart devices. And then we started to think about, hey, how about the cloud was developing? How about we bring all that data from these sensors to the cloud so that we can analyze it with infinite resources and would be able to extract insights and transform applications. And so we switched to a model where devices were becoming dumb again, it's just like producing sensor data and sending everything to the cloud in order to have something happen there. But there are some scenarios where it doesn't work like that. And we are back at a stage where we are starting to distribute the intelligence. We're starting to see a need for having an edge that is smartly intelligent, I would say, and dynamically intelligent. So let's look at some of the scenarios that require having an edge that is smart. And remember, edge is not just the sensor. Edge is anything that is not cloud. So one of the main scenarios we're seeing for having an edge that is smarter is to keep data and secrets safe. So you're an enterprise and you want to have your factory floor starting sharing its data. You do want to isolate from the internet. You don't want hackers to have access to your internal network and so on. So you have to have some level of processing happening down there. Still, you want to benefit from the power of the cloud in terms of training models, in terms of storing data and so on. So you need to find ways to do that. Governments also want to preserve data, of course. And also as an individual, you want the solutions, the services that you pay for to preserve your data, to make sure that you are not at risk of getting your data stolen or somewhere on the dark web. So keeping all that data and secrets safe in that era of connecting everything is key and really leads enterprises and everyone to look at how do we bring some of that intelligence on the edge to not have to depend so much on the cloud. Another scenario which we all know about is the connectivity. Okay, so question by Dick, real quick. Will life is the ultimate edge a direct connection to the human brain, or is this too ambitious and indeed dangerous? That's a good question. I think there's some ethical discussions to be had there. And as I was saying, at the end of the day, edge to me is anything that's not cloud. So yes, maybe the ultimate edge is definitely to have a direct connection to, human parts. We are already having things that are close to our body, right? To a certain extent. We're talking about chips like RFID ones that are embedded into people's skins, under people's skins. Some people do that. We'll see how that turns. So we'll see. I don't know. Is someone, John? Do you have a sister-in-law with a USB connector in her hand? I'd be curious to see a picture of that.
Olivier, there's a more serious point about Azure IoT Edge above that you could reference instead. So Peter,
okay.
when I go about it before, he proposed a continuous deployment solution where he checked in his code, it built it on Jenkins. Jenkins created a container, and then it was Azure IoT Edge deployed on a device, said, am I running the latest version of the container? And if it wasn't, it pulled the latest code down. So that whole continuous deployment model where you check in and then the code gets pushed into your staging production environments is quite a powerful offering.
Yep. Yeah, totally. We'll discuss a bit about this kind of scenarios, but definitely having this kind of orchestrator down there on a device that allows to make sure that these modules, I would say, are up to date and running the latest is definitely super important. And in that scope, general idea of simplifying IoT, providing a runtime plus a service in the cloud that allows to remotely manage this kind of devices in runtime is super important. And it should be here to simplify how people are implementing these solutions. So that's definitely something I'll show you through the Azure Percept device. I'll try and get there rapidly. I think I wanted to put some context here on the whole conversation, and then we'll definitely be able to geek out around IoT Edge and this kind of things. So I was saying another scenario where you need to have this edge a bit more intelligent is the connectivity caveats, right? Your cruise ship, your car are not permanently connected. So you definitely want to make sure that they can connect. The other one is the price of the connectivity. We all understand that, going through a satellite when you're on a cruise ship to send all your telemetry data from your thousands of sensors is not reasonable. And so you don't want to do that. So you definitely want to have a level of intelligence. Last but not least, latency. Do you want your robot arm on your factory floor to wait for a upload, download to the cloud and from the cloud to react to some situation? No, you don't really want that. It's putting people at risk because that connectivity between that device and the cloud, there's some unknown. There's firewalls, there's different levels, different networks. And so you definitely don't want to rely on that. So you need to implement things, locally. You need to be able to leverage what's going on in the cloud in order to, develop that intelligence and then deploy it to the edge. But that's actually bringing an interesting question related to what is the edge. If the edge is anything that is not cloud, then what are the types of devices at the edge? And you need to understand that to develop for the edge. So if I look at these high-level scenarios, and once again, all of that, especially to all of you already in IoT, might seem like, yay, no-brainer, but I think it's important to still have that conversation around, what are the types of devices and where and how will you distribute that intelligence? So in these different scenarios here, whether it's retail, business, government and mobility or industrial, you have the microcontrollers. This is the edge of the edge. This is where things are happening in terms of, activating stuff, capturing data, and so on. These could be directly connected or indirectly, but that's definitely, to me, the edge of the edge, if not these microcontrollers embedded into someone's skins or whatever. But that's the maybe related to the size that they have and their capabilities. Connectivity is the first one that is necessary to make them contribute to an IoT scenario. But then, they can be as little as possible. And we have things that are in, the sense price range that allow to, have some intelligence running, software running down there. Then you have the gateways types of devices. And I named that gateways not especially in terms of their functionality, but more in terms of their size. Think of it as, a Linux box or Windows box that has some capability, manages network, but eventually can run some level of intelligence. Then, we sometimes don't think about it like that, but servers on a factory floor, you might have a beefier machine that is not of a gateway type. Could be a blade in a server rack. That's something that can run some intelligence. We have some scenarios with Azure Stack Edge, which is no more than just a big server at the end of the day that runs some Windows or Linux OS and is capable of running software. And it has lots of RAM, and eventually it has a GPU that allows to do some inferencing for images captured through cameras. And then you can locally have, for example, a conveyor belt on a factory floor that has a camera on top, some vibration sensors, and then locally you can implement very smart AI models that will be able to detect some vibration patterns and eventually detect anomalies on videos, and will automate some processes very easily. When you want to do that, you do require a certain level of efficiency, or I would say performance, from your hardware. And so you need to have more space, right? The GPU, the big fan, and so on, that takes space. So you need to have these beefier, bigger machines. And you need to run more software, you need more RAM, you need more of all of that. So think of it as the edge, always, right? That's still the edge. And now let's me push it a bit further. Private cloud. How about instead of just having a server, you have racks of servers and you have some high-level, way of managing these various servers and distribute the load and so on. That's what we call like private cloud. Azure Stack Hub and the Microsoft realm is what it is. So you go to a Dell or to one of our partners, you buy a solution that basically gives you your own version of Azure, and you have it in your facility. Data stays there, and you have very low latency because everything is wired directly. You could eventually have it mobile, right, on a cruise ship. Some people were able to put Azure Stack Hub on an SUV. I don't know about the battery there, but I've seen that as a demo, and it was pretty cool to see a full Azure Stack Hub. So basically a full Azure embedded into an SUV and delivering, in that scenario that we've seen in that demo, capabilities to first responders in location that were remote for catastrophe situations where people would just drive, or first responders would drive that SUV and then would have capabilities on site to do analytics, to do a bunch of data storage and so on. That is the edge. That is still the edge. And so that brings a question about, okay, we have all these scenarios and all those different types of edges. So how do you bring intelligence down there? How do you develop something that goes, that is trained and then that eventually goes and being deployed there? Let me start with the easy ones: gateways and server class of devices. I'm just putting aside the part which is about our dear friend, the local clouds, because at the end of the day, your own private cloud is no more than a cloud at the end of the day. So not very interesting, but not very interesting in the sense that it's not really anything special about it. Now, let's talk about these gateway types of devices. And as Johnny were mentioning, you can definitely say, hey, I have this Linux box, this Windows box. I'm going to manage that. I'm going to run my own software on it. It's going to be pretty straightforward. It works to a certain extent. How about you go to scale? How about you have an actual customer using that, and you need to be able to monitor hundreds of these gateway types of devices that are deployed at your customers? And how do you maintain the software there? How do you make sure that in a module, a piece of software, an entity running there has a functionality and is still up to date? I'm not even talking about security. I'm not even talking about all these aspects here. So you need to have some way of doing that. And there are out there some solutions to help you orchestrate workloads that need to be deployed on these kinds of devices. Agree with Olivier. So Dick just posted a little comment there saying every definition requires a date stamp because tech progresses so rapidly. Yes, agreed. And that's why I come back to present again and again, because each time it's a little bit different. It's so rapid. I agree with you. That said, the principles stay the same. At the end of the day, when you think about what I'm going to demo in a minute with AI running on microcontrollers, at the end of the day, it's a piece of software that runs on a microcontroller. There's no rocket science here. It's some bits that have been aligned properly that work well. And as a matter of fact, now we have a bunch of tools that allow to optimize that code. So there's an evolution in tech that makes more things possible. The hardware is evolving as well, more capable, more storage, more processing capability. So yes, tech is progressing so fast. Definitions, though, they don't need to change so often. They need to be definitely understood and perceived in different ways with the technology evolving. I agree with you. So let me go back to that notion of how you can manage and train and deploy these modules, these workloads, to the edge on these kind of devices, bigger ones, things that can run something like a container technology. So you were saying, technologies are evolving fast and so on. One fantastic technology that has been developed in the last few years and has been growing, has been really adopted is containers. The ability to package software in a different way without having to repackage a full-blown OS and so on. We're able to package what's needed to really differentiate one application from another. So containers, and that's the high-level vision I have, or the way I'm describing containers. But that's a brilliant technology. And then you have an orchestrator on the host machine that is able to load the right pieces of software in the right places and just execute that. At the end of the day, it's just software once again, but you have a level of abstraction, middlewares, runtimes that make it easier. And so developers can focus on adding the value on top, on leveraging all these tools so that they don't have to restart from scratch every time. And at the end of the day, this is exactly what this is about. So we have an example of that, which is called Azure Iot Edge. For those who are not familiar, that's a runtime that runs on Windows or Linux and allows to manage Docker containers. We're actually using Mobi, which is the open source engine behind Docker. And so we allow something very interesting. So on an edge scenario, on an IoT scenario, you would have this thing creating data, sending them to a cloud gateway for insights to be extracted, some actions to be decided, whether autonomously or by some humans, and commands sent down back to the devices. But here the idea is to be able to containerize these insights and actions to make them as little as possible so that they can fit on these smaller machines, because these IoT Edge devices might be all the way up to servers, but they could be as little as a Raspberry Pi types of device, even smaller sometimes. And so what you want is to be able to just extract from your AI models, from whatever software you've been developing up in the cloud or using in the cloud. You wanna isolate the piece of software. You wanna make it available in form that is small enough so that it could be sent down to that edge and executed down there, so that now your insights are extracted locally and you can take an action locally. One thing which is super important here is to remember this thing that is running that IoT Edge runtime is technology, is something that has a CPU or a microcontroller, has eventually some hardware acceleration, has storage, and has a limited size and form factor, has a constraint, which is a temperature of operation, which is like all of these things that we have at the edge. And so you need to think about the fact that there's a limit to the packaging and the size and so on. So now you have a modularity you can work with, and you have a technology and set of technologies that allow you to create these models, package them, and deploy them. And I'm going to show you a final result of a device that uses IoT Edge. But there are other, as I was saying, other technology that allows to do something similar like that. I like to explain IoT Edge also as this is a package manager. The modules, and we call them modules, not containers, in the realm of Azure IoT. These modules, in the realm of IoT Edge, are Docker containers. But if you think about a model where eventually they are DLLs, for example, you could combine several DLLs and create an application on a device, and that's a packaging. Think about NPM. Right, NPM is a package manager. You can easily deploy packages on your machine, and using Node, you can run them together in order to have an application developed. Node-RED is another good example. You can leverage existing set of modules there, of nodes in the case of Node-RED, and run them down there. So that's in a nutshell, what I wanted to bring up for IoT Edge. I will show you some of it. And before we go to the demo itself, I want to little word about microcontrollers as well in terms of how things are evolving. So when it comes to microcontrollers, and I just ruined my presentation here, no problem. Pretty straightforward. When it comes to microcontrollers, once again, we have something that is able to run software. And so the challenge here is to be able to prepare and package the software, from some tools, whether they're online or on a desktop machine, and run them down there. And there's a bunch of technology allowing you to do that today that will allow you to bring AI at the edge, bring some very sophisticated software that you won't need to really, you need to understand it, but you don't need to master to create applications that leverage them on the edge. Let me switch to the demo. I'm going to put StreamYard aside for a minute here, try and keep the comments aside, so that way if you guys ask your questions, we'll still be able to talk to each other. Let me bring, and don't hesitate to ping me, or tell me that you're here and listen to everything and can hear what's going on. Let me put up my screen here. So this is, actually, let me first do that. Here, this is Azure Percept. I want to use that device for a couple of demos. Azure Percept is some device, a developer kit that you can buy, plus a service that adds a layer on top of what I would say the more granular services that are IoT Hub, IoT Edge Runtime, and cognitive services on Azure. And I'll talk about all of these while we go through, especially if you ask questions. But in a nutshell, Azure Percept is a packaged version of all of these provided as a solution. And so the device here, the DK development kit, comes with a computing unit. It comes with also some graphics acceleration. There is a module called the Eye module, which is camera that has processing power in there. And then it comes with the Ear module, which is a set of microphones that allow for interesting scenarios, as you'll see today. So Azure Percept is more than just that dev kit. There are partnerships that are being established with other companies. The idea is really to demo and to showcase how our IoT and AI technologies can be put together to create solutions for end customers, not for end customers, for developers, to create solutions for their own end customers, without, once again, having to ingest and understand and master all the underlying layers, trying to render, I would say, the IoT connectivity, the containers technologies more mainstream, more accessible, and also, I would say, more a commodity than an actual end, right? So why would you need to be a Docker master and guru in order to just distribute a piece of software that is already packaged on a device, right? So Azure Percept is a great illustration of that. So if you've not played with it yet, let me show you real quick what's going on in the Azure Percept Studio. So that's happening in the cloud, that's happening in the Azure Portal. And the idea here is to be able to manage a set of devices. The first thing I did was to get into the connectivity experience for that device, which you turn it on, it has an access point, and from there you can set up Wi-Fi, and you can start setting up its connectivity to the cloud, right? It's very well documented. You can look at the getting started in videos about Azure Percept. It's pretty straightforward to put together and start. The idea here is that you don't need to deal with the OS. You don't need to deal with the runtime that is there. It's already offering an API, if you will, that allows it to be managed remotely. And all the API is delivered by stacks that eventually, if you want to, you can access to and you can go play with, but you don't have to start with. So because it's something that is about getting started, you can start at a very high level. The first thing is when you boot the device, it comes with a vision model that is already deployed. And what that means is that the device from the get-go is doing something like that. It's able to stream video on the web, so on the network, on the local network, and the camera is streamed into a module that implements vision AI, implements analytics, and is able to recognize a certain number of objects. So that's the default. So something has already been deployed and is already working down there. So here you see it's me, I can wave at you, and it sees a person, it sees a monitor, it says a bunch of things. What I want to do right quick is show you how I can switch that model to something else and how easy that is. I'm going to go to one of these demos and tutorials. I'm going to try one of the sample vision models. It's using my IoT Hub. It's detecting the Percept devices I have on my IoT Hub, which is my cloud gateway for my devices. And here I can deploy one of these models already created for me. I'm going to try, let's say, products on the shelf. I have a shelf, bunch of things. No, actually, let me try the vehicle detection. And what I'm doing here is from my service, as identified in a device, and allow me to deploy that to the device. So here I'm very close to an actual production environment. Here you see it's loading the model on the device, so it's pretty instant. And what I want to do is, because it's a vehicle detection thing, and I don't have cars here, or I can point to a window that has cars running, because there we go. So that thing has been published, and you see it took a matter of seconds, and has been deployed from the cloud, so remotely. Here I have a little video of cars that is running down there. I'm going to put it in front of it. And you see instantly the model in real time is able to detect the cars on that video stream, and just the cars. And you see a little number on top. It's the scoring from the model for that car. Okay. So video never been seen before. The device itself never had any knowledge of this model. I was able to deploy a pre-packaged, pre-trained model up in the cloud that was in the cloud and deploy it on my device. Let me actually revert that to something which is more of a, say, people detection. Oh, actually, I didn't try the products on shelf yet. Let's see if it thinks it's in a retail store or something. It's deploying the model, and we'll see what happens. Any questions so far? Okay, so once again, this is really to illustrate. Yeah.
Sorry. Oh, Paul, you want to go ahead?
Okay. Okay, so I've got a bunch of products here that are showing up on my shelves. So I don't know. Maybe I should open a store and sell everything. That's pretty fun. So let me actually do another thing. I want to look at speech, right? And here I'm on purpose looking at scenarios that are pre-baked for us, things that are just working. Let me look at the speech tutorials and demos, and here we have a couple of them. We have a microphone. There's two aspects to creating a digital assistant or working with audio when you want to do a voice assistant or add this kind of intelligence. The keywords allow you to start the machine for it, or to ask the machine to listen. If you have some smart digital assistants, you have a couple of keywords you know really well. I would not say them because I'm surrounded, and so something will happen if I say that. But you can actually, you'll see very easily create your own one. And then the second thing is the commands, the types of commands you can pass on so that that device will react. And it might seem a bit daunting and difficult, but I will show you that it's not that much. So here I will deploy one of the examples. Maybe I can do. I think I've tried. Well, we're in the automotive scenario, so let's see and if I can do that. Dick is asking, where do you see the key application, medtech, crime prevention, defense, etc. For the vision AI, the main scenarios we're seeing today are anomaly detection, are people counting. So if you look at the industrial automation scenarios, safety, anomaly detection, quality control is a big one as well. In the industrial realm. In smart cities, safety, security, crime prevention could definitely be some of them. In retail, the main scenario could be these days people counting. And a good example of that is, how do you know automatically that there's a lot of people behind a register? so that instead of having to wait for people to complain, you're able to send someone to that register. The other thing is allowing to optimize the flows in a retail store. This is another good example of a vision AI scenario. There's plenty of them, and we have some good IoT shows about that as well, so I definitely invite you to go there. For speech, digital assistants is a good one, but let me show you actually how that would look like. Let's say here what I'm doing is I'm creating a resource, an environment for deploying a speech demo. So Olivier IoT or demos, right? That's going to be the environment. And what it's going to do, it's going to deploy resources for me to show you that speech demo. So there's the device itself that is being receiving, or being configured so that there's a specific keyword that it will be able to react on. And then there's a set of commands the device itself will be able to recognize to then invoke an action and start something. So here, and then in that example for that demo, there's the backend, which is the service that's going to receive the commands from that device to implement something. So here we see a website that will have some animations on it, but at the end of the day, it could be an actual solution. In that case, could be an actual car. It could be an actual, factory lane, this kind of things. Okay, so I'm waiting for this thing to deploy, and once it's deployed, I'll be able to play around with that thing, and then we'll show you how to customize and change things in there. Okay, something happened. There you go. Cool. So here you see I have a dashboard. It's pretty ugly, but once again, it's just a website. It tells me that the keyword is that thing, right? So I'm going to say the keyword, and then I'm going to say a command. And I have no clue what the commands are, but I can see a few things here. And so I'll just use natural language, and we'll see what happens. Computer, and temperature to 68. Oh, it was already 68, right? It was already 68. That's cheating, right? Let's change that. Computer, set temperature to 70 degrees. There you go. Computer, turn the seat on. Yeah, I don't think you got that one. And we'll see what, actually.
Olivier, can I just chip in and ask a question here?
Yes.
It looks a very, very highly packaged solution where you've got sort of the chat between the portal and the Azure Percept device, and it's all very sort of black box. What if I want to put in my own application logic, like if I see a car going across the screen, then that's red, then I would take a picture of its license plate number and send that somewhere. How do I integrate my own application logic?
Totally. And let me get to that, because that's exactly the next step. Here I'm showing you it's super packaged, it's super high level, but actually it's using bits and pieces that are just under to allow you to really do things at a more granular level. So let me actually just switch right now to what's going on underneath. So what I'm going to bring up is the portal directly, and oops, my bad. I'm going to bring back the portal here. So I'm getting out of the Percept Studio, which is the cosmetic version of that demo. And I'm going to go down to my IoT Hub. So the IoT Hub is my hub or gateway for my devices. And in here, I will look at this IoT Edge device, which is my Azure Percept device, and we'll look at what's running on it. So the portal allows me to look at the various modules that are deployed on my device and that have a functionality. So here I see the various modules that are deployed, and you'll recognize the functionality that I've been using. The agent and hub are part of the runtime. The agent really is, the core of the runtime. It allows for, loading the modules and so on. The hub is the one that establishes the communication with IoT Hub and receive the commands to deploy the right modules and control the agent, basically from the cloud. We have a first module called the web stream module. That's the one that grabs the IP stream of the camera and makes it available locally. And so this is the way I'm grabbing that Percept stream here, right? Because I'm just basically streaming an IP address, and that's where the device is sending the video stream. And then you have different other ones, right? There is a device, client here. There is the Azure Ear Speech Client module. So that's the module that controls or delivers the functionality or recognizing keywords and then recognizing commands. There is an Azure I module. This is the one that controls the model that is run in my Vision AI environment or functionality. You have an image capturing module. This one is interesting. When you're training your model, you can use the device itself to capture images. So I can show you that after real quick. And that's definitely one of the ways you can go to from, hey, here is a very packaged solution, just deploy a module, to let me build my own one. So these are just, I would say, just Azure IoT Edge modules. And as a matter of fact, these are not the only ones you can run. If you look at the Azure Marketplace and you search for IoT Edge modules, you will find a bunch of these prepackaged delivered modules, and prepackaged not just by Microsoft, but also by third party. So you can benefit from some level of functionality that is already available in the form of a module you can very easily deploy by configuring the manifest of your devices. So here, for example, there's some that are Microsoft ones for doing analytics. There's some that are third-party, Redis cache-based or Azure Cache and Redis-based type of things. Adida is an interesting solution for orchestrating your IoT Edge module a certain way. Tardabit is another interesting one that allows to bridge the LWM2M world with the Azure IoT one. And so on and so on. You have modules that allow you to interact with Modbus, to interact with CAN, and other things like that in the industrial world. So that's what's going on in terms of the various modules pre-existing. You can also develop your own modules and build them there. So Arjit, I think you're trying to chime in and ask a question. Well, you can type it in. I think we can just have it down there. So let me just follow on that. So these are the modules you can deploy as is, right? But what you can also do is create your own modules, and we have all the tooling in Visual Studio and Visual Studio Code, so you can create code using Python, using Java, using .NET, and package that into a module that is then deployable on your device. And here, if I go back to my IoT Edge device, if I look at the configuration for the modules, right, this is what we call the manifest. It describes which modules are deployed. I can add a new module, right? So whether I add a module from the marketplace, whether I add a specific type of module like Stream Analytics, or my own custom one, I can definitely do that from here, or I can deploy a JSON file to the device so that it can do the work, right? You can then define what we call the routes. The routes are what will allow these modules to communicate with one another. Modules have a set of inputs, set of outputs, all right, and that they basically declare. And the runtime is able to say, hey, the output data coming from this module, I will put it in one of the inputs for that other module. And your logic within the module is able, within your code, is able to understand that. There's also a set of settings. Each module have a set of settings, properties that it can set and that they can report, so you can monitor the behavior, that you can see the values that of some of these properties and so on. And so the routes are defined here, and you'll see it's a pretty query type of way of describing this routing of data. Here from the module, which is the I module, I'll pick all the outputs and I'll send to upstream. Upstream for the hub, the Edge Hub, is the cloud. So here, all the data coming out of the I module, I'm going to send to Azure IoT. And you can continue defining your routes like that. And then you review and you deploy to your Edge device. Here, I'm controlling one device manually through the portal, but then you can do that at scale very easily using a set of APIs that the Azure IoT Hub service offers. So you can imagine having tens of these, Vision AI device smart cameras deployed, and you say, I want to change or update my model for people recognition. Let me deploy to all these devices in this building, and it's going to be one click of a button in my application or one call of an API in the back end or in the background in the application itself. So that's at a high level what you can do. Obviously, it can be way more tricky and way more granular in terms of what you do. Here we see modules that are containers abiding by the Azure IoT Edge, input, outputs, routing philosophy, and so on. But at the end of the day, this is Docker, so you can use IoT Edge to load a Docker module that exposes its own REST APIs or open ports, whatever, and interact with the hardware or interacts with the rest of the world. If you want to have it full control, it's always recommended to work within the boundaries of the IoT Edge, runtime and functionalities. You have a level of security, level of monitoring that is offered by the runtime itself, which has a value, and so you'll definitely want to consider that. So that's at a very high level. Once again, I want to go back to Percept Studio, hoping that what the possibilities are to extend that scenario are. And I want to go back to my speech interface, because what I want to do is I want to show you how I can eventually create a new speech app really quick with a UI for sure. But all of what I'm going to do right now at the end of the day is leveraging some Azure services, which is the speech services in cognitive services, in order to create a new keyword as well as new set of commands for my device. So here I'm going to create a new keyword, and for that I'm going to just pick one up, and something that is recognizable. How can I call this device, right? I want to wake it up with a keyword. I think I was trying Percept in the past. It was not working really well because I'm not good at pronouncing it. So let's say I want to call it Jarvis, right? Jarvis. And it's going to use that speech resource here, and it's going to be English. For now, it's English. And it's going to create a custom keyword in the Azure service. Once again, it's abstracted. I could go back to Azure Cognitive Service Speech interface and do all of that from there. I have the Azure Percept interface to do that, so I'm going to just do that. Okay, so this keyword actually is being created. It's being trained in the cloud. I just have to wait for it to be trained. What it does is it uses that word that I typed in. It assumes it's English, and it will create some AI software that will be able to be deployed so that the device can use that resource, that keyword, right? So I have this one here, and it's not available yet. I'll wait for it to be available, and then I will be able to assign it to my device. Okay, so the training is still ongoing. We'll have it do its thing. Let me go to my commands while it's doing that. So here, I want to create a new project, and I want to create a new set of commands. Let me create a new speech project to create my commands. Olivier demos commands, right? So hopefully this has not been used before. And it's going to be in English. I'm going to just deploy there, and I'm going to use Louis. Louis is the Azure service for language recognition, and I'm going to just create that, and that's going to be my resource to be used. And then I'm going to jump into it in the speech interface on the portal, and that's sending me to that cognitive service speech interface. And this is where I'm going to work. It's not yet ready. Turn home. Let me actually, okay, Speech Studio, see what projects are available there. Okay, come on, Speech Studio, deploy. Okay, so let's see, where are my project? Not here. Never mind, I'll figure it out by coming back here and re-clicking on the link. Let's see if the keyword has been trained. Not yet. Come on, takes more time than I am used to. Let me go back to the speech interface. Let's do that. Yes, now we should be good. So the resource has been created, and I'm now able to go and create my commands that I want to deploy on my device. So here I'm gonna create a command to change the lights down there, right? Set lights to blue, for example. Okay, I'm gonna create that one, and I'm gonna write down a set of sentences, right? And where is it? Okay, I'm here. Set lights to blue. Another one would be set the lights to blue. Okay, that's here. Turn the lights to blue. These are the various ways I could eventually interact with or with my machine to have this command being executed. Cognitive services on Azure will take all of these example sentences and would compile them to create a speech recognition that will do something, right? So that's going to be my set of sentences. I'm going to train the model for me. So cognitive services is doing that. And I'm going to create a rule while it's doing its training. And one of the rules, when I received the command, what I will do, I don't need any type of rules. I'm going to send a speech response. And the speech response will be lights set to blue, right? So that's going to be what the device will speak out. Okay. And I will save that. Simple response, save, perfect. And then I will add an action, which is the activity to client. And in here, I'll be able to set an action, right? Let me go back here and add a interaction rule. Where are they? Oh, custom commands, conditions, actions. Where's my action? Okay, web endpoint, my bad. This is what I need to create first. Create a web endpoint, which is my if this then that. I just restarted everything and I've not been touching that for a long time. Let me see if this URL is down there. Yes, okay, that's gonna be a post. No headers, and I want it to be blue. But here it's a pretty straightforward command. We'll just invoke a web endpoint with that one. And there you go. I've got a new endpoint configured here in my speech. I will go back to my set lights to blue. This one has been trained. And when I'm done here, I should be able to add the action, which should be invoking an endpoint. There you go. That's the one I was missing before. I'm going to pick my if this then that endpoint, right? It's the one that will set my lights to blue. I don't have anything special here to call for. And I'm just going to do a big save here. So on success, action, send the speech response, right? On failure, let's also do that. So let me do that here. The lights are not set to blue. Okay. And on failure, I would say something like failed to set lights to blue. Okay. So if it can't call or whatnot, let's see. Required, no configuration. Perfect. Save. So here I have a command. It's ready to go. And it has a set of sentences that are being trained already. So it allows me to publish them. And let's see, in the dot, I'm all good here. So I should be able to publish that and to have it available for Percept to deploy. Okay. Let me go back to Azure Percept. So here I've been training a model really rapidly, speech model, which is this guy here, that I can then assign to my device. Here, my keyword, refresh, has it been started? No, it's not been started. That's interesting. So it's still using the first keyword. I'm not sure why this one is not being trained. So we'll just like ignore that for the moment and use the previous one. But in the commands here, what I'll be able to do is assign this new one to my Percept device. And so that means that I'm configuring the module on that device to receive that command, to understand that command, which is about turning my lights to blue, right? So if things are working properly, I should be able to wake up my device using the original command. The keyword was computer, but I'm kind of like bugged that this guy is not working here. I don't like that. So why is that one not started? Brush again. Okay, another one. We'll see what it says. How can we call her or he? Could be, help me here. A device, what that? Do that. What it says. And if that works, that'd be good. Okay, so hey device here. We'll wait for it to be trained as well, and we'll see if it works. Hopefully that one will start the training and will work. If not, let's try and see if that command works with the original wake up word, right? So if I go here, computer, set the lights to blue. Oh, my bad, they're already blue. Let me turn them off here first. Okay. All right, computer. It did, actually, the previous one. Cancel that. So it had a little delay. I turned it off. Let me actually prove it works by setting it back to another color. It's pink, touching nothing. Computer, set the lights to blue. Computer, set the lights to blue. There you go, boom. So so I was able to very rapidly use the speech interface, which is a graphical interface for a cognitive service on Azure, to create a new keyword. Well, keyword didn't work. I don't know why. I'll figure that out. And then create a set of commands. Here, just one, very basic. Train that and make it available in my speech service for the Azure Percept device to go pick and deploy. At the end of the day, it is a module that's been packaged by cognitive services, made available to Azure Percept through IoT Hub. And at the end of the day, I configured through IoT Hub the device to load the configuration for the ear module to recognize this new keyword and to recognize this new set of commands and to be able to now recognize a new word here. And I didn't have to code anything. I didn't have to reinvent the wheel. I just leveraged that one service. This is one, among many of these services allowed to make it simpler to configure AI, package these modules, and make them available for the edge. And IoT Edge simplifies that. Azure simplifies that as much as possible. It might look like, and John just like, interrupted me, because yes, it does look like rocket science, like something very high level that has that nice UI and so on. At the end of the day, under the hood, it's using the basic principles of a gateway for the cloud, a runtime on the device, and piggybacks on containers technology in the case of IoT Edge. So that's something that is pretty straightforward to use. APIs are here to help you. If you want to rebuild a UI that replaces what Azure Percept Studio as here, you can definitely do that. You have to do that. IoT Central, which I demoed last time and discussed last time, allows you as well to manage your edge devices in terms of what modules are running and so on, and eventually deploy modules that have been created in the cloud to your edge devices. That's another UI that you can leverage as well if IoT Central is your application. And so that's the way you would address, or you can address, bringing workloads at the edge on devices that can run a runtime like IoT Edge. Once again, containers based, so that means you need to have an OS like Windows or Linux to run Azure Iot Edge. There's some good combination you can leverage as well, for those with no Docker and the intricacies of running Linux containers onto hopefully that clarifies, or that demonstrates correctly what can be done with Percept, what can be done with Vision AI, with speech AI and things like that. I'm not sure everyone is done there, so if you can just like chime in and say, hey, we're still here, Paul, John, because I've not heard from anyone for a long time. Yeah, cool.
I have a
Sometimes
question.
just like talking in.
Yeah, so I have a quick question. Hopefully it's quick.
Yes.
So let's say I'm in the application development space and I really like the image recognition routine. And one of the properties that comes off image recognition routine is like an array of objects that it's spotted.
Mm-hmm.
How would I leverage that? So I would create some application code, publish it in Mobi format, deploy it via Azure Iot Edge, set up on routes so that the properties of image recognition were available to my custom logic block. And then my custom logic would then be able to run using the data coming off that. Is that how it would work?
Yes, that's the way it would work. And you were asking how would I leverage that? And so in the case of our Iot Edge module here, let me bring my screen back here. So here in the case of our Iot Edge module, let me redeploy the object recognition. So we're going to get some data there that will show something interesting. Let me go to this guy here and redeploy the general object detection, right? So let me deploy that again. So this guy is loading the model again. So I'm going to go back home. I'm going to look at my hub here, and I'm going to go to the edge device real quick. And in one of the routes, you'll see that I'm sending the output of the I module, which is the one running the inferencing, running the vision AI model, which is this little guy here, the I module. One of the routes is, oh, my bad, set the modules. Let's go see the routes. So one of the routes is to take everything that is the output of the I module and send them to IoT Hub, right? What I need to do now is to monitor what's going on my IoT Hub in order to see telemetry data delivered by the Edge runtime, which at the end of the day is the output of my vision AI, right? So you can do some logic locally. Let's say you add another module that is behind the I module and say, hey, you recognized a computer. So let me do something there, right? Because in that telemetry flow, if you add a route to that other module of yours that does something when you detect a computer, you can very simply just extract the data from that telemetry and use it locally. If you want to use it in the cloud, let me show you real quick how you could do that, because at the end of the day, it's just telemetry, right? So what I want to do is see the messages coming up there. So let me go back to my IoT Hub. I will start a tool that will allow me to monitor the IoT Hub and see what's going on. So let me get that connection string here, and let me grab my tool. That's a new IoT Hub, so I need to configure my IoT Explorer tool, which is used to connect to an IoT Hub and manage an IoT Hub. So that's something that allows you to see real-time data, allows you to see the different devices. So here you see, I see my Azure Percept device, and what I want to see is the telemetry. And if I start that, I will see the telemetry that is sent by the IoT Edge device to IoT Hub. So here I'm in the cloud. I could have an application listening to the IoT Hub and receiving events from that edge device. And here you see the neural network has some answers. It's the output. It says, oh, there's a TV monitor. You see it in the live stream, right? And the confidence is 90% that it's a TV monitor, and there's a timestamp, and it actually gives me the coordinates for the box as well on the video. And then you continue that. It's a person. The person is 60%, accuracy, and there's a chair. So you can see the three of them here on my stream, and you can see that's the telemetry that has been sent by the module up to the cloud or to another module locally. So the module that is doing the video analytics is basically getting all that data and extracting that piece of information, which is that little piece of JSON that says there is a TV monitor, there's a chair, and there's a person. That's it. So then you have something which is very simple to digest for an application, because the edge device and the edge modules, that intelligence at the edge, extracted the only piece of information you need. It's not sending you a full-blown video, say, hey, here's the video, do the analytics up there in the cloud. It's down there on the device. That makes sense?
Yeah, that's really good. Another quick question. Why did Microsoft choose the Mobi format? I mean, there's this rather popular container format called by Docker, but they chose a completely different one.
It's not different. Mobi is the open source runtime that is used by Docker. That's the same thing.
Ah, right. Okay. So can I use the same containers I would get from Docker Hub on an Azure Iot Edge device? You can.
Yes, you can. Totally, you can. Yes. No difference. It's exactly the same thing. Yeah. So that's there's one of the things I wanted to chat a little. Do we have some more time? I don't recall if we were here for an hour, for 2 hours, or whatnot. So.
It's usually an hour. We can run over a few minutes for questions.
Yeah. So let's go with questions. One thing that I want to bring up is check out a couple things. Let me bring them up real quick over here. Hold on one sec. Doing that, bringing you guys up in that window. And I have a couple of links I wanted to share that have some pointers to some resources if people are interested.
Do you want to find them in the chat, and I'll put them into the comments as well?
Yeah, perfect. We'll do that. Let me quick, there you go, and let me show that slide here so that people have them. And the letter you don't see down there is IoT Show. So the first one is an artificial nose, because a topic I didn't cover that I really invite you to go check out is how to bring AI to microcontrollers, because we talked about bringing them to a gateway class of device with IoT Edge, which is certainly where you want most of your intelligence to happen, because then you can leverage CPU, GPU, and a bunch of things. But then sometimes you need to bring the intelligence even lower. And lower could be bringing them on a microcontroller like this Iot terminal I have here, right? And the idea here is to leverage technology like Edge Impulse, for example, to train models and optimize them in terms of compilation for an MCU, and then deploy them on an MCU for it to be able to use the sensors data and do the analytics locally. And so that's artificial nose project from my buddy Benjamin over here at Microsoft is really interesting, because it shows how you can recognize smells using just a microcontroller and a little gas sensor, and Edge Impulse, which is a AI tool that allows you to compile binaries to be used on microcontroller devices based on an AI model training. But that's at a high level, what the Nose project is about, but it's also now super interesting to see how these technologies are evolving super fast, as we're saying, to allow not only to bring AI on these beefier PC class of devices, but also on microcontrollers. And now the possibilities are more than endless. They are infinite, because you can start doing a distribution of your intelligence all the way down to these tiny devices. That's all I had for today. Hope you guys enjoyed that. Any more questions? Dick is asking, are you able to add an extra layer of security when using this technology for crime prevention? So that's a good question, Dick. So when you're talking about IoT Edge, there is a full stack of security involved. Azure Percept uses that. Not only the encryption of the modules when they're deployed, you can also enforce the signing of pieces of code. You can leverage TPM and other secure storage to store your keys and so on. You can also use some confidential compute, modules, hardware modules that allow you to run some piece of code in them, so that you don't have a piece of IP that can go out there. There is a full integration into tools such as Azure Defender for IoT that will monitor what's going on your network, on your IoT Edge device, in the modules, to make sure that everything is safe and secure. So the short answer is yes. The security is actually built in. It's part of the runtime. And that's one of the reasons why you want to leverage this kind of runtimes. You don't have to reinvent the wheel. It comes pre-packaged with all you need to create a solution, and you can focus on the AI model, the application itself, rather than focusing on the plumbing, which is the edge runtime, the cloud gateway, the security layers, and so forth.
Awesome. Thank you, Olivier. Does anybody else have any questions? We'll keep the channel open for a couple of seconds to give you the chance to ask.
Paul, maybe you could introduce the next talk at the end of this month.
Yep, sure. So we have a special Leeds Tech Fest. It is called Leeds Tech Fest, isn't it?
Yeah.
Yeah, something like that. Leeds Developer Fest. It's a fest. In any case, we're having a bit of a fest, and we're all geeks. So it's all
there's several hundred
Geek Fest
going on in Leeds, and so we're doing a talk as part of that, which is
we are indeed. So we've got the guys from Intel. I may or may not be working there now. I am. And we've got Rob Risney and Vibhu Bithar talking about ideation to inception. And also edge deployments and edge computing and stuff as well. So that's on September the 27th at 6 p.m. So it's on our website, YouTube, which is Paul Wheel's profile. That'll be getting changed. But also LinkedIn, which seems to be quite a fan one for attending. We've had quite a few people on there tonight, which interestingly aren't showing up on my numbers here. That is September 27th, 6 p.m. And we've got Intel doing a talk. And then who have we got lined up for October?
We've only got one 20-minute talk out of an hour, so I haven't published anything yet. So if anyone has out there some talks they'd like to do or some ideas, please contact either myself or Paul, and we'd be delighted to discuss them with you.
We sure would. If you'd like to get in touch, info@iotnorth.uk. We're always happy to give you a platform to talk about things that you're doing. It can be in-depth chats like we've had tonight with Olivier, which has just been absolutely superb as always. Thank you very much, sir. Or if you want to talk about the art of possible or customer use cases and such, like have a bit of a discussion and debate, we're quite happy to give you that platform to do that. And on that note, Olivier, again, thank you very much. John, as always, thanks for the support and help organizing. And on that, good night.